been
This
with the company
conference
for
will now be recorded.
sorry. Craig has been with Train for more than 7 years. He is passionate about the HVAC market and is always looking for ways to make systems more energy and cost efficient. Alongside that, Craig has been active with Ashrae, Alaska as a board member for the past 6 years. And when he's not doing all that, he likes to go outdoors, biking or hiking. Zane is a sales engineer for Mechanical Solutions Inc. He specializes in airside equipment. He has been in the HVAC industry for 6 years, and he has been an active member of ASHRAE for 5 years. He began his career in South Dakota, where he attended university, and he has been living, working, and playing in Alaska for 2 years. So I'll turn it over to you, Zane and Craig.
All right, thank you, Cheyenne. This is Craig here, and thanks for everyone for joining in with us today. We appreciate that. Today's topic is ASHRAE guidelines for COVID-19. So what we're going to go cover, all of this is related specifically to this exact statement. So Zane will get us going here in the next slide.
Afternoon, everybody. So the big question for this presentation is why? Why are we doing this? And the biggest reason is everybody is getting questions about how to make their buildings as safe as possible for their customers and their employees and students even. This presentation explains ASHRAE's recommendations and more specifically where they can find them. We're not going to go too deep into the weeds on specifics, but this is instead meant to give everyone a place to start when they're approached by customers and clients. If specific questions arise, feel free to reach out to Craig or I after the presentation, or go ahead and type them into the chat and maybe we can answer them as we go or at the end. There's also some things that we are not covering. There are several things that ASHRAE mentions that are from like the WHO and the CDC as far as wiping down surfaces, things that you could do for a building as a whole. We are just mainly going to focus on the HVAC side of things. So to start with, what is COVID-19? COVID-19 stands for the Coronavirus Disease 2019. The virus that causes COVID-19 is SARS-CoV-2, and that stands for Severe Acute Respiratory Syndrome Coronavirus 2. Little fun fact, I guess, the spikes on the surface of the virus look like a crown. Corona means crown in Latin, so that's where it gets its name from. The most typical symptoms are fever, cough, and tiredness. There are an enormous list of symptoms, but those are the most common ones. I believe it was somewhere around 60% of people that were infected had these symptoms. So something to keep out and look for.
So we're going to go through several different building guides that ASHRAE has put together. They formed some teams with information about different guide types. So we're going to cover healthcare facilities, multifamily and residential, schools and universities. That's K through 12 through higher education, and then commercial spaces. And commercial spaces that encompasses everything from a small office to a multi-story office building, from a retail to a mall or strip mall type facility. That's what commercial encompasses. And as we go through these, you'll notice that a lot of things we're going to say are the same, and that's because ASHRAE's recommendations for all these facilities are very similar, despite our occupancy changes are different throughout each one of them. But the strategies for how to handle them is going to be very similar. So that will start off with healthcare facilities. So healthcare, a lot of the practices and recommendations specific to this pandemic have already been implemented and have been in healthcare facilities as recommended in the long term. Well-maintained and operated facilities, they've already been doing these things to handle infectious diseases prior to this current outbreak. So there's some additional tools and recommendations that are put forth by ASHRAE. such as increasing our ventilation to help dilute the virus contaminants that are within our air spaces, providing some additional flushing where we're bringing in 100% or maximum outside air, again, diluting our airspace, increasing our filtration. A lot of hospitals or higher healthcare facilities already have MERV 14 or greater filtration required, or even HEPA. But some of the smaller ones, say, you know, like a dental facility, maybe they're in a small medical office building and they're already only operating on a MERV 8 principle or even a MERV 13. So there's recommendations for increasing, enhancing your filtration for those facilities. Exhaust air reentrainment. This is where you have exhaust air that is leaving your building. Well, you don't want to bring it back in through your outside air intakes. So if you've got a potential where that could be, looking at ways to help mitigate that. Say you've got operable windows. Well, if you've got exhaust coming out the side of a building right next to an operable window, you have potential to be bringing that contaminated air back in. So it's important that they focus on isolating those potentials for bringing the outside air where you have your exhaust air leaving the building. UVGI, what is this? This is ultraviolet germicidal irradiation. So this is using ultraviolet to kill microorganisms. We'll go into that a little more later in the slides. Hospitals have already been doing the 120+ degree temperature for the domestic systems. The recommendation is to reevaluate and make sure that that is still happening in the facilities. Basically, go back through and check your water temperatures. If it's being used for sterilizations, make sure it's set at 140 degrees or greater for sterilization purposes. Some of the new things that they're recommending is if you've got a patient wing, so you've got a room that's got 4 beds in it. Well, they're recommending to cut that capacity in half. Now you've only got 2 beds in this room. Well, how do you contain these 2 beds that have 2 separate patients? They're recommending putting some sort of air barrier between the 2 and doing an in-room filtration system that encompasses either a MERV 14 or HEPA filter combined with a UV system, and have the recirculation system separate for each of these 2 spaces to help contain and separate the air streams for each individual patient. Temporary facilities. What's a temporary facility? Well, maybe they put up a temporary vestibule going to a certain portion of the building, inside, exterior. Their recommendation for these are these vestibules need to be maintaining a positive or negative pressurization in relation to the space that they are serving. If you are serving or making a vestibule going to an OR space, then you need to have that space set up so that it is not potentially pushing contaminants into the OR space. You need to have that vestibule set as a negative such that it is not bringing potential contaminants from an OR or an ICU back into a common area, or pushing them into a common area, or even into the OR ICU space. Additionally, one other thing that is recommended is if you have, say, a change of facility structure type, so you're repurposing an OR as an ICU, their recommendations in how you filter the air or how you contain contaminants in those spaces is different. So it's not just, okay, now we've got an ICU, we change out the bed or the room type that we're using, no big deal, right? No, it is a big deal, because air changes per hour, your sterilization requirements, these are different. So it's important to make sure that when you're changing the function of a space, that you also change your HVAC system and how you are cleaning, sterilizing the space to match the new function of that space. This is just a small portion of the number, but there's tons more on the Ashrae website, and we'll make sure to give you that resource at the end. So multifamily and residential spaces. So residential spaces, it's usually those are single residence or maybe a duplex type space. If there's common air systems between multi-resident spaces, they recommend isolating them, trying to isolate your exhaust streams or your supply air streams. Adding in-room portable filtration is also a recommendation. most homes don't have MERV 13 filters. In fact, most homes are a MERV 3 or a MERV 5 filter. Well, they recommend increasing that to a MERV 13 filter for reasons that we'll discuss later on in the presentation. They also recommend adding UV systems to your buildings, to your residence. You know, in the case of, say, a multi-story apartment building or condo facility, you have a lot of common areas. So how do we isolate that? Well, the recommendation is those common areas need to be maintained in a negative zone such that they aren't pushing contaminants from one residence into another through an under door cut or an open doorway. We want the residences to be positively pressurized and the common areas to be negatively pressurized. These are simple strategies. They might be hard to implement because not every existing building was designed with this in mind. But if there's a common exhaust fan for a common area, leave it running 24/7. That way you're maintaining negative airspace in that area. They also recommend air circulation in a residence. If you've got a ceiling fan, turn it on. It helps to circulate the air through the space, thereby decreasing the chance for a airborne pathogen to deposit on a surface and grow or be picked up by another passing occupant. There's also several strategies that we'll cover a little bit later about DOAS or heat recovery in high performance multifamily or residential facilities.
So moving on to schools and universities, they have an extremely wide variety of different equipment, from cabinet unit heaters to full custom air handlers. Ashrae's first recommendation for schools and for other building types is to check existing equipment to make sure that it's operating as it was designed. This can include revisiting your O&Ms, your as-builts, test and balancing reports, even going and possibly doing a new test and balance to make sure that the equipment is operating as it was originally designed. Ashrae has put together checklists for reopening schools, which I know we're seeing here locally. So this could potentially be useful, starting with checking the outside air and increasing your outside air. And with that, they're trying to make sure that we're following Ashrae 62.1 for the number of children that are in the space. As many of the engineers know, kids need a lot of outside air. With just there's being a lot of people in the space, you got to have a lot of outside air. Ashrae is double checking to make sure that yes, we are doing that, and then possibly if you can increase it even more. They're also looking at doing air flushes before occupancy. So possibly before a week, like when the teachers arrive at schools, they're running the systems for a week to move that air, to get all the systems cleaned out essentially. And then when school is in session, running the units 2 hours before people arrive, or possibly 24/7 if possible. And again, simple things like replacing filters, and then we get into some more complex things like reviewing control sequences, such as setting up an epidemic mode, which you'll see in a couple of our slides. We can also look at the demand control ventilation if you have CO sensors for occupancy. If we can bump those up, Ashrae's recommending between 800 and 1,000 parts per million, but that could even be low for your specific building type. And last building type that Ashrae goes through are commercial spaces, which again are most of the spaces that we are interacting with others. So these are your grocery stores, your office spaces, places that you and I are all working. Ashrae has several recommendations, and some of them are HVAC related and some are not. First and foremost, they're saying to go back and check your systems to make sure that they're running as they were originally designed. And part of that includes ensuring that the building conditions meet Ashrae standard 55 for space temperature and humidity. when they're keying in on humidity again, between 40 and 60%. The reason for that is it reduces the half-life decay time of viruses, and we'll talk about that a little bit more. And then the same thing, we're increasing filtration and outside air as much as possible, and also increasing building pressure. So if we can do a positively pressurized building, that's always good, in most cases, I should say. And then also setting up a epidemic mode in your BAS system so that your building, like I said, runs a couple hours before any occupancy is there, or it runs 24/7 to maintain outside air and getting the building flushed.
So there's a lot of different system types that we see. We've really broken it down in three categories in a simplistic form. We've got our airside systems. So this would be, say, air handlers, VAVs, terminal units, fan coils, things of that nature. That's anything that's going to move air through a space. And I'll get into why we've broken out the packaged rooftops in a separate line. And then we've got our hydronic systems. So that covers anything from our boilers and our heating plants to our domestic hot water systems. And then we've broken out packaged rooftops and DOAS type systems because these are typically not using discrete DDC for controls. So, and they're more of a compact assembly of a system of parts and pieces. So they're a lot less flexible in terms of how we implement our changes or upgrades to our systems in mechanical or control strategies. So we've broken them out because how you tackle those is slightly different than how we would tackle either of the other two hierarchy of systems. So with our airside systems, right? So we kind of went over this, right? So we have air handlers. We have heat recovery systems. We have the DOAS and the packaged rooftops. We have our fan terminal units or VAV boxes, shutoff boxes. All these systems encompass our airside type systems. Each one of these has potentials for adding increased filtration if your brake motor horsepower allows for it. Each one of these has the potential for adding in-unit or duct-mounted UV systems, and each one of these has the ability to make control strategy changes in how we operate the unit. And we'll go into some discussion about how each one of those. But this is real simple. Like, we know these are the systems. We know this is what's in our building, and Ashrae has recommendations for how to tackle each one of these. Heat recovery is a unique one in sense that if you have a heat wheel system, which we don't have a lot of in Alaska, but heat wheels have an inherent cross-contamination amount, and most systems have a built-in purge. So one of Ashrae's recommendations is increase that purge percentage such that you're purging more of your exhaust air stream, trying to clean your wheel with your outside air more frequently, or if that's not a possibility, to put your system into bypass 100%. That way you're not having the potential for cross-contamination on your wheel system. So again, filtration, this ranges from anything within your discrete equipment that you already have, or adding an in-room filter, or adding a discrete power type filter where you've got a recirculation, like a fan coil in a room, right? What's its job to do? Well, maybe we add filters to that system to increase it, and it's serving, you know, room A versus room B. Exhaust systems, this encompasses anything from a building pressurization system all the way down to a bathroom and exhaust. General recommendation from Ashrae on this is operate your bathrooms 24/7 at this point. That's their best recommendation, because this will help maintain a negative pressure in a space that has got a higher likelihood of contaminants collecting and being present. There's always people that'll be blowing their nose or washing their hands in the bathroom. So, you know, If we can maintain a negative airspace in there, it's less likely for airborne pathogens to migrate into a common area or into a tenant space or other. Unit cleaning. This feels like a bonehead thing to say, but maintenance and facilities, a lot of times filters get focused on, belts they get focused on, or things that are more visible to persons that are in a space. They don't always think about, if I open the unit up, should I be cleaning that drain pan? The answer is absolutely yes. This is a potential for collection of dust and particulates, and to become a growing ground for pathogens, bacteria, and virus. Dampers on a building. Your return air dampers are usually situated upstream of your filters, which means all they're doing is recirculating your building air. So they're picking up all that dust and debris and they're bringing it back. So it's recommended to clean these dampers on a more regular basis. If it hasn't been done annually, they're recommended to increase that, semi-annually or even monthly at this point. Coils are in the same boat. Coils shouldn't be cleaned once every 10 years, or when suddenly you realize you don't need filters because the pressure drops so high through your coil, it does all the filtering for you. They need to be cleaned more frequently than that. So this is just a renewed effort of clean your equipment, maintain your equipment. On our hydronic systems, there's three major points in here. You've got your heating systems, your cooling systems, and your domestic systems. So most heating systems will run our boiler temps warm enough that we don't have to worry about pathogens potentially growing in the space. If you have a low temp water-based heating plant, the potential for pathogens to grow, it is there. Ashrae's recommendations for Legionella is the most popular topic, and name obviously is 120 degrees, which is why we try and put that as our lower limit. It doesn't mean it will stop it, it just means it'll mitigate it to the most effective form. If we can increase those temperatures, that helps. So their recommendation is increase those or add some sort of biofiltration where possible. Cooling towers are in the same boat. They are a breeding ground for everything disgusting. If you've ever seen a wonderful YouTube video of cleaning a cooling tower, I don't recommend it. It's quite disgusting. They don't get cleaned nearly as often as they should, and they don't have nearly the filtration that should be recommended to filter out all the biocontaminants that they pick up and collect on a regular basis. So this is a renewed effort of clean them more regularly, add filtration where possible, whether it's on the water side or the air side. And on domestic systems, going back through and checking your heating plant and making sure that you are actually maintaining 120 degree minimum fluid temp. 140 is more ideal for killing pathogens, but as a bare minimum, 120 degrees Fahrenheit would be the minimum recommended by Ashrae.
So kind of switching gears to package rooftop units, DOAS units. Typically, a lot of the rooftop units are a lower cost unit. There are, of course, exceptions, but it may be difficult to increase or add UV specifically to the units themselves. There are still things that can be done to ensure proper operation. Number one is clean those units. And we're not just talking just drain pans, wipe down the inside of units, get into the corners, clean off the air intakes. Sometimes we get cottonwoods stuck in those air intakes, and that can be a thing that traps other particulates. And for God's sake, replace filters. You've no idea how many times we see units that get sucked into fans because the filter's been in there for 2 years. Check the intakes and make sure that the intakes aren't too close to an exhaust. And that's not just an exhaust fan. That could be, there are vehicles parked below the units and the exhaust pulls into the rooftop unit, and then you just blow that back into your building. and is increase your outside air as much as that furnace will allow. So if you can adjust the outside air damper, most are set from the factory for 10% or maybe a little more, but usually we see about 10%. If you can open that up to 15, 20% and your furnace can still meet set point in the building, then Ashrae is saying go for it.
So we've kind of covered our equipment types and what we should be doing and what we should be renewing to do and adding to, as well as building types. So what are some of the recommendations, the high level things that that Ashrae is recommending? And this is us pulling through just some high level ones that are the most recommended and the most effective as Ashrae is found. There are dozens of other things you can do, but these are the things that that Ashrae is focusing on as the most effective. So we've got filtration that we'll go through. We've got UV systems to go through, our humidity controls, and then as well as control upgrades to your facility. You know, whether it's a DDC type thing or whether you've got a programmable thermostat, there's things that we can do to make changes, and we'll go through each one of those.
Starting with filtration, mechanical filtration. We know filtration. We've said in this presentation a million times that Ashrae is recommending increasing filtration up to MERV 13 or greater if possible. The reason why Ashrae is saying that is because they have quantified that the size of the particulates that are in the air that are carrying this virus that are being passed between people via our saliva is 1 micron. That's what Ashrae is sticking to, and until somebody tells me otherwise, that's what I'm going to go with. And at a MERV 13 filter, we're looking at an 85% efficiency of catching a micron. So that's why that recommendation is there. If you can go up to a MERV 14, that number jumps to 90% effectiveness. If you can implement powered air cleaners, so things that set in the space, that's a great option, or up in the ceiling. The other option is we're seeing powered filters now that use an ionizing technology that goes in air handlers or in the ductwork. So those are all options, but essentially anything that we could do that's above a MERV 13, we're heading in the right direction.
So I've said it a couple times, ultraviolet germicidal irradiation. So what it is using the UV spectrum to kill microorganisms. So UVC has been found and tested by multiple parties over the years to be the most effective at killing microorganisms. And that's UVC is the spectrum, the nanometer range of 200 to 280 nanometers, with 265 to be found the most optimal wavelength, but in that range for killing viruses, bacteria, etc. So recommendations that are coming from Ashrae is, you know, if we have the systems already in place, it's recommended to make sure you have new UV tubes, replace them. There is a recommended by manufacturers of how often you should be replacing the bulbs for most to be maximum effective. Recommended to keep doing that or get on top of it if you haven't been. There's also options of retrofitting to air handlers, rooftops, or even small, like a fan coil inside of a room, dedicated. Some manufacturers do a dedicated unit specific to that in-room recirculation. So these are all really simple and easy ways, and it's best to work with the manufacturer and with the facility and the owner and director to see if this is a strategy that makes sense for the building that you would like to implement this into. Sometimes you can't do that. So what's your next best course? There are several units that are designed that sit in a room and they recirculate, you know, like a little portable filter. We've all seen them, and we may even have them in our homes. Well, they make these with UV built into them as well. So if you can't do a dedicated system, get one of these small units, plug it into the wall to recirculate and clean the air that you have available. What if that's not even an option? Well, they make portable decontamination UV bulbs, basically. You know, you pick it up and you carry it around, or you set it up in a room, you evacuate the room of all people, and you turn the high intensity bulbs on and you let it run for an X amount of period, and it irradiates every surface that is seen in the space with this system. So there's a lot of applications and uses for how UV can be used, and Ashrae is definitely, they're behind UV because it is a proven technology and measure for killing microorganisms, and is in the case of our pandemic that we're sitting in right now, is definitely a highly recommended course in action.
So the next very important topic is humidity, and I think this is something that gets overlooked a lot of times. We see humidity pop up in healthcare facilities, but Ashrae has done extensive research on why proper humidity control is so important. They have pinpointed 40 to 60% as the sweet spot for comfort and safety. Below 40%, your mucous membranes begin to dry out, and you become more susceptible to viruses and bacteria. That's a huge thing for us here in Alaska. When it's, you know, anything below 20 degrees, 30 degrees, our humidity is not there. So it could be very important to have a humidifier in your space. The other end of that is if you get above 60%, then you have the potential for mold growth, which can also make you very sick. So some options for this is you can have in-room humidifiers. You can go down to Costco and buy a humidifier if you want. There are some issues with those because a lot of times they will sit overnight, or they sit over the weekends, and they can actually become a place for mold growth. So if you do have one, take a second, wipe the inside of it down so that container's not sitting overnight. A better option is a full system humidifier. So we see these in air handlers. You can get them in rooftops as well. And these are actually designed to maintain a full building humidity. So all of your spaces can meet that 40 to 60%. So if you have the option for it, or if you already have one installed, turn it on, use it. It's a valuable tool.
So with control systems, there's a variety of ways that we can handle this. So I think an earlier slide, Zane mentioned for schools, right? Where demand control ventilation. Let's go ahead and change that to 800 to 1,000 parts per million as a recommendation, or potentially even lower, based on your occupancy and recommendation. So, well, one of the other recommendations is also just disable it entirely. What's the reason behind that? Well, demand control ventilation has a good side. When you have lots of people, it increases the amount of outside air based on a CO2 concentration level. But if there's nobody in there, it decreases it back to nothing, which means you're bringing in less fresh outside air and you're recirculating more of your indoor air. And this goes against the design of trying to dilute out and clean your space. So if the ability is there to disable demand control ventilation, DCV, it's recommended to do that. Create an epidemic mode. So what is an epidemic mode? Well, this is a button that a facility person can basically click, one button that says, we're going to maximum outside air, 100% if possible. We're going to bypass any heat recovery system we have, and we're basically going to flush the building, because we've now reached an epidemic where suddenly, you know, someone gets sick, or maybe there's 2 or 3 persons that are sick and it's been notified, and they're like, we need to flush the building. Maybe it doesn't happen at the first second it's notified, but it happens as soon as possible. You know, if you've got a multi-story office building with dozens of tenants in it, you want to keep all of their safety in mind. So by doing this, you're basically saying, I have your guys' safety in mind. I'm going to forget about energy efficiency. We're going to run the boilers wide open here in the middle of winter, bring in all the outside air we can, and we're going to dilute any contaminants we have in the space. We're going to negatively pressurize our tenant spaces so we can draw out any potential pathogens and exhaust it, and then replace it with clean, fresh air from outside the building. of course, going back and making sure that we do not have our exhaust air reentrainment issue going on. That's also an important thing to verify. So trending, you can look at trends of spaces based on occupancies of persons versus outside air. This just is a good metric and easy way to verify that you are putting forth strategies to ensure you're bringing in the cleanest and the freshest air that you're available to maintain a higher indoor air quality. Purging. So this has two ways you can look at it. You can do it in the mornings, purge your building, again, maximum outside air. You're trying to get maximum number of air changes per hour to flush the entire building's air system. Also, at the same time, do it post occupancy. That way, it's after everyone's been in the building, you're going out and you're flushing it all before you turn the system off. That way, there's no chance for any contaminants to settle on surfaces that you don't want it to settle on. Occupancy changes, alternatively, versus turning your system off, there's also a recommendation by Ashrae that if you can, don't turn it off. Leave it running 24/7. I think I mentioned this earlier in one of the previous slides, of the building guide slides, was the goal is to maintain air circulation in the space. So if you have your air continually circulating, you're reducing the chances for airborne pathogens and contaminants to deposit on surfaces that may become a communal space for more than one person to touch and spread the viruses that we are trying to mitigate away from. Airflow monitoring. Zane highlighted this beautifully. A lot of equipment comes from the factory at a 10% outside air. Well, what if we want to increase that? Okay, so we change the little rheostat to say 20%. Is it actually bringing 20% in? Well, we're not really sure. Get a balancer. Make sure you're actually doing that. Or if you have a system in place that can monitor and measure outside air, make sure you're actually bringing in that amount of air as required. That way you're not shortchanging yourself and you're not just guessing with a pie in the sky kind of attitude towards it. You're actually doing what you intend to do, and that is increase indoor air quality. So kind of to wrap this up, what are some real high levels? Like if you were to go talk to a client, they came to you and you didn't want to throw down 30 minutes of information of what you're supposed to do, right? Well, there's 4 keywords that make this really easy, right? We're trying to dilute the contaminants in the space, disabling demand control ventilation, bypassing heat recoveries, adding purges, increasing outside air. These are all ways to use to dilute contaminants in the space. Exhaust. We're trying to exhaust contaminants from the space. So that means running our restroom exhaust systems 24/7, putting common area spaces into negative pressurization. There are some good methods there. Contain. This is looking at containing any contaminants that may be in the space, as well as containing the clean environment that you are trying to maintain and the higher indoor air quality. Indoor air quality isn't just number of pollutants in the air, whether it's a piece of cotton or a virus. It's also our humidity. Maintaining a temperature and humidity that complies and is in standards with, or in compliance with Ashrae standard 55, that makes the most sense. We want humans to be comfortable inside of our spaces. So trying to maintain for that, that's the most important. Cleaning your air. UV systems, higher filtration. These are the 2 most effective methods by Ashrae to clean the airstreams that we have. So one other thing that we didn't necessarily highlight here, but is recommended and stated by Ashrae, is there's conflicting information in regards to using bipolar ionization systems. So right now, Ashrae is not recommending the use of them in occupied spaces because there's too much conflict of interest with studies that have been done. And even though there's decades of information on them, Ashrae's recommendation is sticking with outdoor air quality, filtration, and UV systems as the most effective methods at treating and increasing our indoor air quality.
So lastly, we put together a resource page. In this presentation, we can send out to whomever wants it. I believe it's going to become available here at the end. Ashrae has done an amazing amount of work. They have an entire group of people who are volunteering. They're pulling information from hundreds of different sources. And Ashrae has put together a very conservative outline of what to do for different buildings, different types of systems, anything you can imagine. So hopefully, between this presentation and with the resources that are presented here, you have a decent starting point. If somebody brings up a specific question for you, you can at least have some place to go. If not, Craig and I have done extensive research on this, thousands and thousands of pages of skimming through information. So we do have a fairly decent idea of at least where to start. So if there's any questions, again, reach out to us. We've seen a couple questions come up. Thank you, Dave. Much appreciated on the answers. And there is a ton of information. So Ashrae's done a great job of narrowing it down to the HVAC side of things, as well as helping with some non-HVAC side of things. So if I was gonna say, if you guys do have any specific questions, you can go ahead and pop them into the chat, and we can try to answer them now, or we can reach out later. Do you have anything else, Craig?
Yeah, I just want to say thanks very much for jumping on, and we do appreciate this, and we're all in this together. So Zane and I have tasked ourselves with researching a lot of information that Ashrae has put forth. It's far more than our two minds can contain, which is why Ashrae has dozens of people that have been put together in this. So if we're unable to answer the question or help you find the resource within the documentation available of how to address the question, we have a list of contacts within Ashrae's organization, as well as other members of Ashrae and the society, that we can pull together and help address any concerns that you or owners of buildings or any client that we may have or encounter to get the solutions we need to help us through this time.
With that, we'll pass it back to Diane.
Oh, thank you. We do have a question on the chat. I don't know if you wanted to address this. It's from Charlie. He's asking, is there any data on how long COVID-19 virus can survive on surfaces and in the air?
Dave nailed it.
Oh, yeah. Okay. Okay.
It's there's
I did not see the answer.
That there's can affect how long it survives on surfaces, but the key thing that Ashrae took away was keep the air moving. The more outside air, the more dilution you have, the less chances that you have, the less chances that things are going to rest on the surface unless people touch them. And that we didn't really touch on because, again, that's a different topic of cleaning and limiting people, things like that. Mm-hmm.
Okay. I don't see any other questions on the chat, so just wanted to thank you everybody. Thank you everybody for going on the meeting today. Thank you, Zane and Craig, for the presentation. I hope people found it informative. Like we previously mentioned, the meeting was recorded and it will be available on demand on the chapter website. That's www.ashraealaska.com. And if you have questions or concerns, please don't hesitate to contact any of us. Again, yeah, we will see you all next month. Information on the next meeting will be available soon. So thank you, everyone.